Here are the answers for the Section 6-3 homework, starting with page 219. We're asked to give a formula that relates the variables c and d. Now in the video, I've shortened up the sentence. You're going to want to look at the book and see the complete wording of the sentence. We're told that the circumference c varies directly as the diameter d. In general, when you're told two variables vary directly, the formula connecting them is y equals m times x if the variables are y and x. Then the letter m represents the rate. We don't have y and x, we have c and d, but we're going to use the same pattern as this basic formula. So c equals m times d. Now in the directions it tells us that the question will either tell us what m is or it's implied. In this case, it's implied because we know from geometry that circumference equals pi times d. So our value of m is the number pi. Now number 3, again, the original sentence is longer, but here's the key part of the sentence. The distance d traveled by an object in 12 seconds is proportional to the rate r. Following the basic pattern, y equals m times x, but using d and r instead of m and x, we get d equals m times r. But remember that the value of m is given to us in the problem. So let's look at the question again and see if we can figure out the rate. If a certain distance can be covered in 12 seconds, then 1/12 of the distance can be covered in 1 second. So our rate is 1/12. Distance equals 1/12 times r. Number 5, in a 20% discount sale, the discount d varies directly as the list price L. The basic setup for a varies directly situation is y equals m times x. But we don't have y and x. We have d and L. Now we're told that the value of m is going to be given to us in the problem. That's 20%. We can say that the discount price equals 20% of the list price. Number 11, we're given a table of values and we're asked, is there a linear function that contains these points? For these points to be on a linear function, there has to be a constant rate of change between them. Let's find the rate of change. When this increases by 1, y decreases by 1. When this increases by 1, y decreases by 1. And when this increases by 1, y decreases by 1. There is a constant rate of change between y and x. So the answer to the question is yes, this is a linear function, and we're asked to give the slope. We're asked to give the rate of change. So when you give the slope, remember you're finding the change in y on the top and comparing it to the change in x. The little triangle symbol is a Greek letter delta. It represents the word change in. So y is changing by -1 units every time x changes by +1 units. The slope is -1. Now we're asked if this is a direct variation. In order for this to be a direct variation, it must satisfy the formula y equals m times x. Remember that our value of m is -1. So this has to satisfy the equation y equals -1 times x. Let's check to see if it does. Take any one of the ordered pairs. For instance, the first one is 3, -1. And substitute those values in for x and y. Y is -1, and the x is 3. Does this make a true equation? No, it doesn't. So this is not a direct variation. It is a linear function, but it's not a direct variation. Number 13, to decide if it's linear, let's check the rate of change. When x increases by 1, y increases by 2. When x increases by 1, y is changing by 2. And again here, when this increased by 1 unit, this one increased by 2. This is a constant ratio. So yes, this is a linear function. Therefore, it will have a slope. The slope is the change in y divided by the change in x. Y increases by 2 units every time x changes by 1 unit. This reduces to 2. Now we want to tell if this is a direct variation. If it is, then it fits this equation. And remember that we're saying that the slope is 2. So our ordered pairs have to solve this equation. Let's check to see if they do. We'll check the first one, 2, 4. Y is 4. Oops, I see that I had written an M right there. I didn't mean for that to be an M. That's an X. Anyway, back to this. Y is 4 when X is 2. Does this produce a true statement? Yes, it does. This is a direct variation. On page 221 written, we're given some information in a sentence, and we're asked to solve for a letter. We're told y varies directly as x. That means y and x are related with this basic formula. Now we're given values of y and x. When y is 30, x is 5. I've substituted them into my formula. This will allow me to solve for m. When we divide by 5 on both sides, we find out that the rate is 6. Now we can rewrite our formula and actually fill in m with a number. We're asked to find y when x is 15. So let's substitute 15 in place of x. 6 times 15 is 90. In order to find one letter when given the other in a direct variation, we went through some steps. We first found the value of m. Then we found the value of the letter we were looking for. Let's try number 3. We're told C varies directly as D. Therefore, it must fit this pattern. C equals M times D. We're given values of C and D. Let's substitute them. 12 pi equals M times 12. Now solve for M by dividing by 12 on both sides. We get M is equal to pi. Pi is a number. It rounds off to 3.14. But we'll just leave it as the pi symbol and recognize that that is representing a number. Now we're asked to find C when D is 3. So let's rewrite our formula, but now that we know what M is, fill in pi. Then replace D with the number 3. We get as our answer 3 pi. Number 5, we're told D varies directly as the absolute value of T. That means we have the formula D equals M times the absolute value of T. 2 corresponding values of D and T are 60 and 2. Let's make those substitutions. 60 for D and 2 for T. And now solve for M. 60 divided by 2 is 30. Hey, now we know M is 30, so let's rewrite our equation and put the 30 in there. Now we're asked to find D if we substitute -1/2 in for T. Let's make that substitution. The absolute value of -1/2 is +1/2, and 30 times 1/2 is 15. Number 7, we're given an equation, and we're given a value of y and a value of x, and asked to find k. So let's make the substitutions. In place of x, fill in 5. Now let's solve for k. 5 plus 2 is 7, and 5 times 7 would be 35, so k has to be equal to 5. Number 11, we're given the proportion arrangement for a direct variation. We're used to the equation y equals m times x as the basic formula, but another version of this is to write the relationship using a proportion. Anyway, if we start with this proportion, we're asked to prove that this equation is true. Let's do that in the space over here. I'm going to rewrite the original proportion to give myself room to do some algebra. I'm going to think about what I want to create. On the left side, I want to have x1 times y2. I have an x1 over there, but it's not in the top like I want it to be. So I'm going to take the reciprocal of both sides. x1 over y1 equals x2 over y2. In essence, I raised both sides to the -1 power. Next, let's multiply the y1 to move it to the other side. Next, let's multiply the y2 to move it to the left side. Notice that we have created what we are asked to prove, and every step was a legitimate algebra step. For the review assignment, we're back to the questions where we're asked, does this relationship make a function? For a relationship to be a function, each x value can only have one y value with it. When you have a graph, what you want to look for is to make sure that there is no vertical overlap between parts of the graph. I don't see any place where one dot lines up vertically with another dot, so yes, this is a function. We're asked to give the domain. So for the domain, I'm going to have to look at the actual drawing in the book. I can't just look at my quick picture of the dots. The domain of a function is all of the x values. The dot on the left has an x value of -1. This second dot has an x value of 0. This next dot has an x value of 1. The next one is an x value of 2. And this last dot has an x coordinate of 3. Number 4, is this a function? No, it's not. Because of this first portion here, there are all kinds of dots on this segment, and they all line up vertically with each other. So this represents a whole bunch of dots that have the same x coordinate, but different y coordinates. Because it's not a function, we're not going to give the domain. Number 4, we have a list of ordered pairs. Is it a function? Well, let's see. When x is 3, y is 2. But I notice later on I have x is 3 again, and I have a different value of y. So there's not only one y value assigned to the x coordinate of 3. This is not a function. Page 215, we're given a formula for function p, and we're asked to evaluate that function using a minus 1 as our input value for x. So let's make the substitutions. Fill in a minus 1 for this first x, and then fill in a minus 1 again for this x here, and then on the end there's the plus 1. Now let's simplify this. We want to square this binomial. It makes a squared minus 2a plus 1. Then in here we want to distribute the -2. We get -2a plus 2. And on the end is a plus 1. Now combine like terms. -2a and -2a is -4a. 1 plus 2 plus 1 is +4. Number 15, we have a function rule for f and another function rule for g. We're asked to multiply these two values together. Well, we first need to find them. So let's first find f of 3 by substituting a 3 into the rule that gives us f. That turns out to be 6. Now let's find g of 3 by putting a 3 in for g. 3 minus 3 makes 0. 6 times 0 is 0. Number 19, we're asked to graph function f, which is equal to the constant number of 0. So the value of the function is always 0, no matter what is used for x. We're asked to use a bunch of integers for x. So when x is the integer -3, the value of f is 0. So you put a dot at a height of 0. When x is -2, the value of f is still 0. You get a horizontal row of dots. And these dots do continue forever to the right and forever to the left. Now we're going to regraph it, but this time use any real number for x. This time we don't get separated dots, but we get dots that are infinitely close together. We might as well just draw a straight line. There's our graph. Number 23, give the domain of function t and then make a rule for it. The domain is all of the x values. It looks like there's a -1 and a 0 and a 1 in that first row. Now we're asked to give a rule that will find us t of x. There are different possibilities. One that I noticed right away is that these answers for t are the absolute values of these numbers for x. So one possible rule is to say the absolute value of x. That is not the only answer you could have given. Number 29, we have a rule for r and another rule for t. We're asked to do a composition. Let's first find t of a. So that'll be our step 1. Take the rule for t and fill in an a. We get a plus 1 squared. Let's expand that. A squared plus 2a plus 1. Now that we know what t of a is, let's fill it into the variable for rule r. That'll be our step 2. We have 3 times a squared plus 2a plus 1, and then minus 1. And let's simplify this. 3a squared plus 6a, 3 times 1 is 3, but then minus 1 makes plus 2. Number 33, we have a rule for function p and another rule for function q. We're asked to do a composition. We're asked to first plug in c into the rule for q. Let's do that as our step 1. Where the x is, fill in c. There we go. We can't get any better than that. Now let's take that result and substitute it into the x in function p. That'll be our step 2. So we have 2 parentheses, and then fill in the c over 2 minus 3, and then plus 6. And let's simplify this. 2 cross cancels 2, leaving c. 2 times -3 is -6, and then when you add 6, you get nothing. The final result is just the letter C. Okay, question B, we're going to do it again, but in the opposite order. So first substitute a C into function P. That'll be our step 1. 2 times C plus 6. Now that we know what P of C is, let's substitute it in place of X in function Q. So we have 2C plus 6 all over 2, and then minus 3. This reduces to C plus 3. And 3 minus 3 cancels away, leaving the letter C. On page 211, we're given a set of ordered pairs and we're asked for the domain and range. The domain is all of the x coordinates. That's an x, that's an x, that's an x, and that's an x. We seem to have a 1 and a 2. The range is the set of y coordinates. That's a y, that's y, that's a y, and that's a y. It looks like we have 0 and 1. On page 212, we're given an equation to find y in terms of x. And we're asked to find the values of y for these 7 integers. So let's substitute each of these numbers into that equation and find the answer. This is -3/2, or -1.5 when you do a mixed number. Next row, let's fill in -2. This makes -2/2, or just -1. Next row, fill in -1. And this makes -1/2. I think I see a pattern happening. This next one will be 0, the next one will be 1/2, the next one will be 1, and this last one will be 1.5. Now we can give the range. The range is all of our y values. We have -1.5, -1, -1/2, 0, 1/2, 1, and 1.5. We're also asked to graph it. So when x is -3, we got -1.5 for y. Let me put a mark here for -1 and a mark here for -2, and then find a dot halfway between those two marks. When x is -2, y is -1. When x is -1, y is -1/2. 0, 0 is on there. And by now, you probably see the pattern going uphill. Number 14, here's our equation for y in terms of x. Find the value of y when using these 7 integers for x. Let's substitute those numbers. -3 squared makes +9, and then in front of that is a negative. -2 squared makes +4, and then in front of that is a negative. -1 squared makes +1, and in front of that is a negative. This one makes 0. This one makes -1. I think I see the pattern starting to develop. We're asked to give the range, so a list of our y coordinates. We have -9, -4, -1, and 0. Now we're asked to graph. When x is -3, the y value is down here at -9. Whoops, this should have said -9, this one should have said -4. When x is -2, the y value is -4. When x is -1, the y value is -1. And 0, 0 is on there. Then 1, -1, 2, -4, and 3, -9. Number 10, here's our inequality. It would help us to make the chart if we solve this for y. So let's subtract 3x from both sides, getting -2y is less than -3x plus 7, and then divide by -2. The arrow switches, we get 3/2x minus 7/2. Now let's make our substitutions. Fill in -3 for x. This makes y is greater than 3 times -3 is -9/2 minus 7/2, which is -16/2, the same as -8. Next row. This makes y is greater than 3 times -2 is -6/2 minus 7/2, which is -13/2. It's the same thing as -6.5. Next row. This makes y is greater than 3 times -1 is -3/2 minus 7/2, which is -10/2. That reduces to -5. I think I see the pattern. It looks like it's changing by 1.5 units each row. So this next one will be y is greater than -3.5. This next row will be y is greater than -2. This next row will be y is greater than -0.5. And the next one will be y is greater than +1. I hope that I changed by 1.5 each row without messing that up. Now let's get our range. The first statement says y can be anything greater than -8. And then the other statements say that y can be anything greater than these other numbers. But putting them all together, I think the most expansive of the statements is the first one. Y is greater than -8. We can confirm that when we make our graph. All right, on the x-axis, let's label from -3 over to +3. On the y-axis, it looks like the farthest we ever need to go downwards is to -8. So let's put 8 marks going down. When x is -3, y is greater than -8. Go to -3 on the x-axis. come straight down vertically. When you get to -8, put an open dot. It's got to be an open dot because the arrow doesn't have the or equals to. And then to show that y can be anything larger than -8, you draw a ray going straight up the paper. Second row, when x is -2, y is greater than -6.5. So find -6.5, mark it with an open dot, and then draw a ray straight up going through where x is -2. Next row, when x is -1, y is greater than -5. 1, 2, 3, 4, 5. That's this mark right here. And then draw straight up. Make sure you stay vertical so that every dot on this ray has an x-coordinate of -1. When x is 0, the lowest y value is -3.5, right there. And then draw straight up, tracing the y-axis. When x is 1, our lowest y value is at -2. And then everything greater than that. When x is 2, our y value is at -0.5. And then draw up from there. And when x is 3, our y value is at 1. On the y-axis, I probably should have had a mark there to be 1. And then draw straight up. Now that we have the graph, we can confirm that we do have a nice straight diagonal line worth of the dots. That way I know that I didn't mess up when I was going row to row. We can also tell that a range is in fact greater than -8 because the lowest y value we'll ever see is -8, and then the rays go up forever.